Okay, in this video, we're going to learn how to find the inverse of a matrix. There are three methods to find the inverse of a matrix. The first method, we call it as adjoint method, where we are going to use the formula A inverse equal to 1 over determinant of A multiplied by matrix adjoint A. The second method is by using the property, where in the question we can find AB equal to K times identity, where K is a constant, I is identity matrix. The property that we are going to use is when A multiplied by A inverse, it will become an identity. Okay, the third method is elementary row operation, where we have augmented matrix A and the identity, and then we are going to use elementary row operation to change A to become identity, and identity will be changed to A inverse. Okay, finding inverse by using adjoint method. First, we have to find the determinant, and then we are going to find the adjoint matrix, and then we are going to use the formula 1 over determinant multiplied by adjoint matrix A. Okay, in this formula, the symbol A inverse is not equal to 1 over A, because this we does not read it as A to the power of negative 1. This is A inverse. And the determinant A cannot be equal to 0, because when this one equal to 0, it will be undefined. Any number, when divided by 0, it will be undefined. So, because determinant of A is not equal to 0, we call it as a non-singular matrix. An inverse matrix exists. If determinant of A equal to 0, A is called a singular matrix. Therefore, inverse matrix does not exist. When A is a singular matrix, the inverse matrix does not exist. Okay, adjoint matrix. Okay, let's see, be a cofactor matrix of A. So, adjoint matrix, that is adjoint A, the symbol, is defined as the transpose of the cofactor matrix. That is, adjoint A is equal to C transpose. And remember, cofactor is defined by negative 1 to the power of I plus J times minor ij. Okay, the symbol here we can see it is alternate positive and negative. Why? It is positive and negative because here it is negative 1 to the power of 2. This is negative 1 to the power of 3. This is negative 1 to the power of 1 plus 3, 4. This is negative 1 to the power of 3. This is negative 1 to the power of 4. This is negative 1 to the power of 5. This is negative 1 to the power of 4. This is negative 1 to the power of 5. And this is negative 1 to the power of 6. So it is easy to remember how to find the cofactor with the symbol positive, minor, negative, minor, positive, minor, and so on. Let's look at the example. Example 21, find the adjoint matrix A, 3, 1, 5, 4. Hence, find the inverse of A. So, to find the adjoint of matrix A, first we have to find the matrix cofactor. So, matrix cofactor is plus M11 minus M12 minus M21 plus M22. This is equal to positive, the determinant when we delete the first row, first column. So we are left with 4. Okay, the second cofactor is negative multiplied by minor. We will delete the first column, second row. So here it is 5. The third cofactor is negative. We will delete the second row, first column. So we are left with 1. And the fourth one is, the first cofactor is positive multiplied by minus 2. That means we are going to delete second row, second column. So here is 3. Remember, this symbol is not modulus. This is determinant. In the case of determinant of, let's say we have determinant of 1 is equal to 1. Determinant of negative 2, let's say we have, that is, determinant of negative 2 is also negative 2. This is not modulus, remember that. So the answer will be 4, negative 5, negative 1, 3. This is matrix cofactor. Therefore, the adjoint of matrix A is the transpose of the cofactor, that is 4, negative 5, negative 1, 3 transpose. So we have transpose means the first column will become the first row, 4, negative 1. Second column will become the second row, negative 5, 3. So the inverse of matrix A is equal to 1 over determinant of A is 3 times 4 minus 1 times 5 multiplied by the adjoint of A, that is 4, negative 1, negative 5, and 3. So the final answer will be, this is 12 minus 7. So the answer is 4 over 7, negative 1 over 7, negative 5 over 7, and the final element is 3 over 7. So this is the inverse of matrix A. Example 22. Find the adjoint of matrix B, 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. Hence, find B inverse. Okay, to find the adjoint of matrix B, first we have to find the cofactor. Cofactor C is equal to, remember this is plus M11 minus M12 plus M13 minus M21 plus M22 minus M23 plus M31 minus M32 plus M33. That is the matrix cofactor. Then we are going to complete this formula. So this is equal to a big matrix here. We will put all the cofactors. So this one, we have to delete the first row, first column. Delete the first row, first column. So we are left with 2, 2, negative 1, 0. The second one will be negative, and we will delete the first row, second column. So it will be 0, 2, negative 2, 0. The third one will be positive. We are going to delete the first row, third column. So the minor here is 0, 2, negative 2, negative 1. Okay. Next one will be negative. We will delete the second row, first column. So here the element is 3, 2, negative 1, 0. Next one will be positive. We are going to delete second row, second column. So the element will be 1, 2, negative 2, 0. The next one, we will delete second row, third column. So the element here is negative 1, 3, negative 2, negative 1. For the next cofactor, we are going to delete the third row, first column. So it will be positive minus 3, 2, 2, 2. Third row, second column. So this is negative. The minor is the determinant of 1, 2, 0, 2. And for the last entries, we are going to delete the third row, third column. So this is positive multiplied by minor 1, 3, 0, 2. Okay, and then we are going to evaluate. Okay, when we evaluate, we will have 0 minus negative 2, that is 2. And then here we have 0 minus negative 4, which is 4. 4 times negative, it is negative 4. The next one will be 0 minus negative 4, which is 4. Okay, the next, in the second row, we have 0 minus negative 2, which is equal to 2. 2, here we have negative outside, so this is negative 2. Okay, the next element is 0 minus negative 4, which is equal to 4. Okay, the last element in the second row is negative 1 minus negative 6. Negative 1 minus negative 6 is 5. 5, we have negative outside, so we will have negative 5. Next element will be 6 minus 4. 6 minus 4 is 2. And the next one is 2 minus 0. 2, but we have negative outside. The last element will be 2 minus 0. 2 minus 0 is 2. So this is the cofactor of matrix B. Therefore, the adjoint of matrix B is equal to the transpose of the cofactor, that is 2, negative 2, 2, negative 4, 4, negative 2, and the last row will be 4, negative 5, 2. So this is adjoint. And then we are going to find the inverse of B. To find the inverse of B, we have to find the determinant. To find the determinant, it is easy because we already have all the cofactors. So we can choose any row or any column that we want to find the determinant. Let's say here I want to find the determinant by using the expansion along the first row. So it will be B11 C11 plus B12 C12 plus B13 C13. So the element of B11 is here and the cofactor is here. The element of B12 is this one, 3, and the cofactor is negative 4. And the last will be 2, and the cofactor will be 4. So we are going to multiply all the element and cofactor and add it all together. So we have 1 times 2 plus 3 times negative 4 plus 2 times 4, which is equal to 2 plus 8 is 10. 10 minus 12 is negative 2. So that is the determinant of matrix B. So once we have the determinant and adjoint, so it is easy for us to find B inverse, where B inverse is given by 1 over determinant of B multiplied by adjoint of matrix B, which is equal to 1 over negative 2 multiplied by the adjoint B, that is 2, negative 2, 2, negative 4, 4, negative 2, 4, negative 5, 2. Okay, and then we are going to multiply the constant inside the matrix. So we have negative 1, 1, negative 1, 2, negative 2, 1, negative 2, 5 over 2, and the last item will be negative 1. So this is the inverse of matrix B.